All right, guys, so we're talking about mathematical inductions here. So mathematical induction is all about, proving that a statement like this one, which is true first, okay, to prove that it's true first, and then for the next steps to come. All right? That's all about it in a very nutshell, easy way to explain it. So what do we have here? We have a sub n, I will call it a sub n. It could be b sub n if you want to. Which is the sum of k equals to 1 up to n of k to the third power equals to n squared times n plus 1 squared over 4. So we want to prove that this part here, the left part, is the same thing as the right part. Okay? So that's what we want to do. So what we're going to do is we're going to do it in 2 steps. So we're going to talk about the induction start, okay? And then we're going to do induction step. All right? So in 2 steps. So induction starts. All right. So with the induction start, what's going to happen is what? So I have a sub 1 here. So that means I'm going to replace n with 1. All right. So usually we use integers, positive integers. But sometimes the instruction might tell you that, is n is not equal to 1. It could say n greater than 1, n greater than 5, n greater than 10. So it depends on the problem. But here, since nothing was said, so you can go with n equals to 1. All right? So when n equals to 1, so what's happening is now we're going to take 1 and then replace it back into the statement here, into the equation. So that would give us what? So 1 to the third power, all right, because n is 1 now, so k equals to 1. So to the third power equals to 1 to the second power times n plus 1. So that means 1 plus 1 squared over 4. All right, we good? So now we're just going to do the calculations. So now 1 to the third power is equal to what? It's 1 times 1 times 1. Okay, so that will give us 1. And then this is equal to 1 squared is what? 1 times 1, which is 1, times 1 plus 1 is 2. We know that. And then 2 to the second power is 2 times 2, which is going to give us 4 over 4. All right? So this operation here is it's easy. 4 divided by 4. So 1 equals to 1. So this is a true statement. So this is a true statement. All right? So if this is a true statement, so that means that we can also assume that. So assume that a sub n is also true. Now, so what are we going to do? So the next step is to go with the induction step. So now the induction step is all about what? It's all about, so if a sub n is true, then we have to prove that a sub n plus 1 also is true. So in other words, so that means we're going to have, so the sum of k equals to 1 all the way to n of k to the third power equals to n. So if, let's don't forget to put the if here. So if this one is true, so we have n squared times n plus 1 squared over 4. So if this is true, then we're going to have sum of k equals to 1 all the way to n plus 1. So it's no more n, but it's n plus 1. All right? You guys with me? Of k to the third power. And this is equal to what? So this is equal to n plus 1 to the second power. All right? And then inside you have n plus 1 plus 1. Okay? Also to the second power over 4. All right? So this one is the next step. All right? So for induction step, we say if a sub n is true, then a sub n plus 1 also is true. So this one is a sub n, correct? Then this is a sub n plus 1. All right? So if that's what the case is, so what's happening here? So this is the same thing as n plus 2, correct? So n plus 2. So I'm going to keep this one on the side here. So that's the same thing as n plus 2. So what we're trying to do, ladies and gentlemen, is to be able to now prove that this also equality here is true. Okay? So that statement is true. So now the proof. So we're going with the proof now. So we're saying we want sum of k equals to 1 all the way to n plus 1, k power 3, so which is equal to what? So we know that n plus 1 is the next step. So because that's the next step, what do you need before the next step? Is the step before. So that which is the a sub n, correct? So that means we have sum of k equals to 1 of n, k to the third power, plus, now what's going to happen? N plus 1 to the third power, this one here. Let me explain this very quickly to you. So this is a sub n plus 1, correct? Now, a sub n plus 1 is a sub n plus n plus 1 to the third power. That's it. So it's like when you're talking about number 3, right? Before you get to 3, what do you have? You have 2. So it's 2 plus 1 is 3. Are you guys with me? All right, so let's go at it. So what we're trying to do now is to make sure that this side here of the equal sign is the same thing as what we want to prove. Okay, so let's go at it. So now, my next question to you is, what is this one? Do we know it? Yes, we do, because that's just a part of our early statement. Okay, so the sum of k equals to 1 all the way to n of k to the third power is equal to what? Is just equal to n to the second power times n plus 1 to the second power over 4. And that is equal plus n plus 1. Are you good? All right, this is very interesting. Okay, we're loving it so far. So this now is the operation that we have to do and make sure that that's the same thing as the one that, we're trying to prove, correct? So what can we do here? So this is the sum of two expressions. We have the lowest common denominator, which is 4. So automatically, we don't need to think too much. This one is then the 4 goes here, plus 1 to the third power over 4, all right? So the lowest common denominator is 4. So that would then be, to make the adjustment, 4 will multiply this one here, that expression. So what do we do? So next step very quickly is to be able to, now somebody can think about what? To expand this problem. But if you expand it, it's just going to make matters worse. So the best thing to do is to look at the two expressions, because you have one expression here, the other one here. What can we do? Can we factor it? Yes, we can factor it. So what do we have in common? We have n plus 1 to the second power, which is in common. All right, so that'll be our greatest common factor. And then whatever left outside the parentheses, we put them together. So we have n squared left for that one, plus 4 times n plus 1. Ladies and gentlemen, this is where it gets a bit tricky. Because when you take n plus 1 squared out of n plus 1 to the third power, what is left? N plus 1. So the common mistake that a lot of people will make is that they will forget about the n plus 1. And once you do that, your final answer is definitely going to be wrong. All right, so keep an eye on that. So once we have this now, so this is n plus 1 squared. Now we have to work this out. N squared plus 4n plus 4. So what we have inside the parentheses now, is there any way where we can work on that? We can make it better, looking better. The n squared plus 4n plus 4. Can we do anything about it? Yes, because this one is a trinomial. Trinomial with 3 terms. So what can we do with a trinomial with 3 terms? We can factor that also. You guys remember, you can go back to our previous videos as when we worked on AC method with trinomials, how we factor them up. Or what I could do is also, better yet, to link it to this video, so it's going to make your life a lot easier. So what's going to happen? We have AC method says what? I'm looking for 2 numbers that will multiply to give me 4, and the same 2 numbers add up to give me 4. What are those 2 numbers? 2 and 2. Because 2 times 2 is 4, and 2 plus 2 is 4. So what does that translate to? That translates to, we have n plus 2 to the second power over 4. Because if you guys are not sure about it, just take that same expression here, n plus 2 squared, and then expand it. Expanding it means what? Take n plus 2 times n plus 2. And then you get n squared plus 4n plus 4 back. Now, what do we see here? This is just the same thing as what we're trying to prove, ladies and gentlemen. All right? And that means that we just proved the fact that if we're coming from a sub n, if a sub n is a true statement, then A sub n plus 1 also is a true statement. Take your time, go back, look at the problem, take the steps. We're talking about induction start, and then we're talking about induction step. All right? You see how we did it? If you keep that up, you're not going to get it wrong. Okay? All right.